Okay. Don't cry. Miss Palacios needs 2 1/5 pounds of corn, whatever. When she went to the grocery store, she found a package of 1 3/8 pound. What fraction of a pound does she still need? So we're finding the what? The remainder. So what operation are we doing with these two numbers? Subtraction. No, it's like a math problem. So we have 2 1/5 minus 1 3/8. Okay? So to subtract fractions, what do we need first and foremost? Common denominator. So what do 5 and 8 have in common? 40. So it's going to be something over 40, something over 40. How do we get from 5 to 40? Times 8. So we have 8 40ths. How do we get from 8 to 40? So 3 times 5 is? All right. Here's the second part where we get in trouble. Because now we have 8 40ths minus 15 40ths. Can we do that? No. So we think back to how we learn to subtract. So let's say our problem was 31 minus 14. Right? This is totally separate, just a reminder of how subtraction works. Can we take 4 away from 1? So what do? We borrow. We take 1 from the tens place. So this goes down by 1. Becomes 2, but it goes down by 1. And then we increase the ones place by 10. Okay, because there are 10 ones in 1 tens place. So 10 plus 1 is... Okay, trust me. Okay? So now we say 11 minus 4 is 7. 2 minus 1 is... Okay. So that's how it works with whole numbers. The same thing happens with fractions, except it's a little bit more complicated. We take away from the ones place, so this goes down by 1, and then we add how many 40ths makes up one whole? 40. So what do we add to 8? 40. So we say 2 and 8 40ths is the same as 1 and 48 40ths. So that's why we make it more complicated over here, so you can see what actually happens when you borrow. Instead of just saying we take 1 away from here and we put a 1 in front of that. Okay. I like how we go from that was, why do you show it's all complicated? So wait, no, I don't get it. Okay. So 1 and 48 over 40 minus 1 and 15 40ths. The reason we do that is now can we take 15 away from 48? Yes. 48 minus 15 is? So we get 33 40ths. How about the whole numbers? What's 1 minus 1? 0. So our answer is just... There you go. You can't simplify that, no.
Did you learn subtraction in first grade?
That was 40 years ago. Okay. We take one whole number away, right? How many 40ths makes up one whole? If we split this into 40 pieces, how many 40ths does it take to make up one whole? 40. So we add 40 40ths. So what's 8 40ths plus 40 40ths is 48 40ths. Okay?
Okay, let me write this down.
Sure does.
40 plus 8.
Where's the button? All right, number 2. Dimensions of the rectangular prism are 8 by 4 by 5. Okay, so we can draw that. Someone just asked what number 2 was? Because it's right here. Okay? And we have a scale factor of 1/4. So can we find the volume of the original shape?
Yes.
Yes. So we say V is big B times the height. But since it's a rectangular prism, the base is really just length times width times height. So we say what is 8 times 4 times 5? 32 times 5. What? 160. Okay? So that is our original volume. Now we could redraw the prism. And we could divide all the sides by 4 and refine the volume. But that's not the best way, because they're not always going to give you the side lengths. So what we remember is our handy little formula that says that the new volume is equal to the original volume times the scale factor squared?
Yeah. Scale factor cubed.
It's scale factor cubed because we're talking about volume, and volume is in.
The scale factor is now 16
Not quite.
16 times 4.
So we say our original is 160 times our scale factor is 1/4 cubed. So the top part's pretty easy. 1 times 1 times 1 is 1. The bottom is going to be 4 times 4 times 4,
16 times 4.
which is 16 times 4.
Which is
Okay, times 160. So really what this is going to come down to is 160 over. We can simplify that. They're both even. Whoops, too far. So we can say this is 80 over 32. If we divide them both in half,
40 over 16.
which is 40 over 16. They're still even.
20 over 8.
So we can go 20 over 8, 10 over 4, and 5. And then we can divide 5 halves. That's just, it's just 2.5. So our answer is 2.5 feet cubed. So could you have gotten that same answer if you had divided 160 by 64? What do you think you'd get? You would have gotten 2.5. No. Can I go up? Yes. Will I go up? Yes. So really, here's the work that's important. This whole simplifying, that's just to get a final answer. But this is the idea we care about. If you're changing volume by a scale factor, you take the original volume and multiply it times the scale factor cubed. Sure. All right, number 3. Integers are whole numbers. So if we make ourselves a handy little number line here, if we think what square roots that we know are close to 85? What square roots are those? So, alright, square root of 81, which is 9. And we could keep going just for fun. So we say the square root of 85 is in between 9 and 10. Closer to 9. Okay? And that's it. Hopefully we get all those right. No. What extra work? Bar graph. I made a piece of a number line. Yes, you should make the number line. That will help. All right, number 4. Ugh. Yeah. Cylinder water tank, radius 3.5, height of 4.5. The tank is full. We pump the water out. 32 cubic feet per minute. How long till it's empty? All right. So if our tank is filled with water, we care about what?
How much water is in it?
So what is that called? Volume. So we need the volume of a cylinder. Okay. So it says it has a radius of 3.5, height of 4.5. We have our formula. Area of the base times the height. Since it's a cylinder, what formula are we going to use to find the area of the base? No, it's just pi r squared. I know you don't have to memorize the formulas, but at some point you should memorize the formulas for area, because always helpful to know. We'll use 3 for pi for now. Our radius is
3.5 squared.
focus. So 3.5 squared. So 3.5 times 3.5. So it's 5, 2, 17. Bring down the 0. 15. I'm going through it. If you're not helping me with that, then shush. 10. Thank you. That helps. Oh. 5, 2. Alright. So we do get 12.25 times 3. Well, 12 times 3 is 36. 3/4 is 75 cents. So that's the area of the base. So what do we have to multiply that by? Because a big part of 7th and 8th grade is learning how to work with decimals. Just think, once you get to algebra, decimals go away a lot. Yeah, which is just in time for you to have calculators. Yeah. We spend half the time in algebra, we don't even use calculators. I know, I just want you to know that. Speaking of that, alright, so we get 165. Let's round this off to 0.4. That is the volume. So that's a big part of the question. But what is it actually asking you?
How long until the tank will be empty?
Alright, so how can we figure out division? If we're losing 32 feet per minute, we think 32 times what number equals 165. Since we don't know that, we work backwards. We say, what is 165 divided by 32? Can 32 go into 16? No. Can it go into 165? Yes. About how many times? Well, let's think if it was just 30. 30 times what gets you close to that? Let's try 5. So what's 32 times 5? That's 160. I don't think we're getting any more than that. Positive. And then 32 goes into 54. So we get about 5.1. So if it says approximately how long will it take, we can say about five minutes. And so really there's a couple of skills you need to know here. One is being able to use the formulas for volume. Hopefully we can do that. That's just a matter of substituting in numbers. Second thing is knowing how to do decimals, which that just takes practice. I can't teach you guys how to do decimals. That's something you got to learn through practice. Can't use a chart though. And then the third skill is just being able to read the question. Because I'm sure one of the answers, if this was a real test, would have been 165. Sure. All right, Miss Moreno bought 2 dozen marbles for $2.25. Because why not? When you're married, you get bored, I guess. You can start a marble collection. How much did each one cost her? Yeah. So it's 24 for $2.25. So how can we find the cost for just one? We divide. So it's $2.25 divided by 24. Right. If you're not sure which number to put where, if we got rid of the decimal, if we said if it was just 24 for $2, and then we think if we switch around, if we said 24 divided by 2, we would have gotten 12. Would that make sense that she paid $12 per marble? No, so we know dollar amount goes in the box, marbles goes out of the box. You need to be careful when you put your marbles outside of the box because you don't want to lose your marbles. It's kind of bad. And when I say kind of, we mean absolutely bad. Except for the kids who are like, what? Why would I care if I lost my marbles? Can 24 go into 2? Can it go into 22? Can it go into 225? Since 24 is just a little bit more than 22, that means that going into 225 is probably going to be a pretty big number. So let's try 9. So 6, 3. So 216. If we subtract, we get 9. 24 goes into 90, about 3. But then if we think we're talking about money, right? How many decimal places does money go to? 2. So we can say about how much does it cost her? About 9 cents. So you need to be careful how you write money because some people, they want to be like, it's 0.09 cents. That's not correct. If you wanted to write it as a decimal, you have to put $0.09. If you wanted to write it as 9 cents, you'd have to literally put 9 cents. I would recommend putting the dollar sign. Sure. Okay. Not a bad deal. All right, NASA spacecraft. Okay, cool. Travels 2,800 million miles over the course of 5 years. Okay. Okay, there's no people on board. No. Okay. Because the sad news is when you send something on a 5-year trip to Jupiter, it doesn't come home. Yeah. It took 5 years to get there. And then you're going to try to somehow spin it back and get to come. Alright. Okay. Alright. Also, it doesn't actually take gas to go through space because there's no... Alright, never mind. So 5 years ago, 2,800 million miles. On average, how many miles to travel per year? So if this is the total for 5 years, how can we find for 1 year? We divide this. So we say 2,800 divided by 5. Do we need to write out this whole number, or can we just leave this as million? This is going to be just fine like that. Okay, we're going to see why. So 5 goes into 28. 5 times 25, 3. 5 goes into 30, 6 times. If there's nothing left over, what do we do with this last 0? Bring it up. So how far does it go in 1 year? 560 million miles. So that's part 1 of the answer. But it wants it in scientific notation. So we start. We're gonna. Oh. Okay, stop. So if we just write this out with all the zeros, so 560, and let's put in a couple 3 zeros. What number is that? 560,000. That's not quite it. What if we put 3 more? 506 million. Okay, check. That's what we want. So now we know the decimal starts out, as of right now, right at the end. But in scientific notation, we know we need to move the decimal so we get a number between 1 and 10. So where's the only place we can put the decimal that'll give us? Okay. So that's part of our answer. It's 5.6 times 10. Okay. Okay. Here's where some kids will make the mistake when they say, now you just count the zeros. You don't just count the zeros, you count however many places the decimal moves. So we went 1, 2, 3, 4, 5, 6, 7, 8. So this is 5.6 times 10 to the 8th power. Hey. So 5.6 times 10 to the 8th. Right? Number 7, spinner has 8 sections, so we can make ourselves a little spinner here. What? Okay. 8 perfectly even sections.
Oh, yeah, that's awesome.
Hush. So we have 3 black sections, 2 green, 2 white, which is now going to be orange.
Why orange?
Because white doesn't show up too well on a white background. And 1 brown, which is now purple.
Why not brown?
Is that, whatever. I'm trying to help you out because you guys probably don't have all these colors. So. I've literally gone over 7 of these questions with you. You're complaining about me giving you too much work. Like, what do you want? Okay. What's probability of getting black the first time? 3 out of 8. Okay. How about white the second time? Is it 2 8s or 2 7s? If we land on a spinner, does that remove the space? So, spinners almost always independent. Okay, great. So we can simplify this. So 2 8s is the same as 1/4. So then 3 8s times 1/4 is 3 32s. And there's your answer. All right, number 8. We went over this one on day 2. If the Stevens save $4,400 for their vacation, so what is the most money they can spend?
4,400.
So 4,400. So what symbol do we put in here? The total they spend has to be less than, which means it eats the left side. I have to remember that sometime. I forget. Okay, this included $1,200 for travel. So do we have to do anything with that, or is that just $1,200? They pay $1,200 no matter what they do. They're also paying for something else, which means we need to put in what kind of symbol? Addition. Yes. Okay, then it was $80 per day. So how much would it be for 2 days? 160. How about 3 days?
So it's basically 80 times that.
We're not there yet. 240, which means it's 80 times however many days there are, which we can call x. Good job, Jeffrey. And that's it. Doesn't tell you to solve it, so we're all done from there. All right. Point R is at negative 5, 4. What would the new location be under the translation x plus 3, y minus 4? This is actually not that bad. All we have to do is we take this rule, x plus 3, y minus 4, and we just substitute x and y for our x and y coordinates. So x is negative 5, y is positive 4. So our answer is going to be whatever negative 5 plus 3, and then 4 minus 4. So negative 5 plus 3. Remember, if they're different signs, we subtract them, and then we keep the sign of the higher number. So which of these numbers is higher, 5 or 3? 5. So this is going to stay negative. And then 4 minus 4? 0. 4 minus 4? 0. And there's your answer. Don't what? Don't move? Can't stop me. What is the effect on the circumference of a circle if the radius is doubled? Well, so the scale factor is equal to 2, since it's doubled, correct? Right? Then you think about circumference. How many dimensions do we measure circumference in?
1.
Circumference is 1. Because all it is the distance on a line, so it's just a length. So if we use our formula of nu circumference equals the original circumference, not that we can perceive. Original times the scale factor raised to what power? 1. So all it is going to be the original times 2 to the first power. What's 2 to the first power? It's just 2. So what is... Because circumference is measured in one dimension. So what's going to happen to our circumference? It's going to be times 2. So our circumference will double. Circumference. What if it said, how will the area change? That would be the original times the scale factor squared. So that would be 2 squared, so it would be the original times 4. No. If you increase the radius, the entire shape would get bigger with it. If you change the radius of a circle, it changes the entire circle. It's not just saying pick a different number. It's saying you literally change the circle. Wow. And you can't just put it got bigger. That's not how that question is worded. You have to specify by how much. Yes. So don't lose that. Tell everyone to go home and watch if you learned something. And if you don't, ask me to give you a free 100 on it, then maybe.